Good morning, everybody. Working a modified JEE problem. Now, recall what a geometric sequence is. We'll start with the first term, followed by the first term times something called a common ratio. We'll call it R's common term for this, or designation. The third term would be FR squared. And then we keep going, but I'll just do one more term here. So you can see a successor is equal to the predecessor times R. Okay. Anyway, this is an example of a geometric sequence. Now, what we have here, again, this is a JEE problem, modified. It's a test they take in India to get into prestigious colleges, I think. Now, X, Y, and Z are specified as consecutive terms of a geometric sequence. We're also given this innocent-looking statement, Y over X is a member of Z, plus, and that, y'all, these are the positive integers, they're sometimes called the natural numbers. Now, and then the mean is actually the second term plus 100. The mean of the three terms, when they're summed and divided by 3, is the middle term plus 100, okay? So the question is, how many geometric sequences possess these properties? All right. Now, this very first condition that doesn't look like much is actually quite valuable. Y over X reduces to a positive integer, and so that means we can rewrite it as Y is equal to NX, where N is also a positive integer. So N is a member of the positive integers. All right. Now, that's really quite powerful, because what happens, we have X, Y, Z all of a sudden in this form. Okay. And as this is written, these would be the first three terms of some geometric series. Okay. Now, let's see what we can do with the rest of the information. I've written most of it down already for you. This is called the arithmetic mean. I just call it the mean, but a lot of people like to call it the arithmetic mean. It's a mean with respect to addition, contrasted with the geometric mean, which is a mean with respect to multiplication. And so all of this information is just given, okay? And we already know that Y is equal to X times N, right? Okay. The rest of this, folks, is just plain algebra. I won't say much about it. What happens is something rather nice. You'll notice right here that this right here is just the very same thing as X times N minus 1 quantity squared. Okay. And you can see that we get an equivalent statement here where we get X in terms of N. Now, remember, N would be the common difference, what we call the common difference, the same as the R in the above example. And so for X to be an integer, for X to be an integer, 300 has to be divisible by perfect square. So let's take a look at 300's prime factorization. See, 300 is equal to 2 squared, which is 4, times 3, of course, times 5 squared. Okay? So what's evident from this prime factorization is that 1 is always going to be a perfect square factor, right, of anything, so that's trivial. So 1 squared, okay? But then you were going to have 2 squared also as a perfect square divisor of 300. 5 squared, okay? And then also, let's not forget 2 times 5 squared. Quantity squared, right? Yeah, but what are these guys? This one would be what? This is 4. This is 25 right here. And then this is, of course, 100 right here. So those are the only, so the answer to these are the 4 possibilities, right? Now, so we could already answer the question and say the answer is 4. I mean, let me. In other words, that's the answer to the question. I'm gonna say a little bit more, but 4 is the answer. F-O-U-R. 4. 4. Okay, so there's 4 such geometric sequences with the aforementioned properties. Now, but let's go and take a look at some real life situations here. Notice right here that for n equals 2, we get the 1 squared case, right? Okay. And for n equals 3, we get, that's the 2 squared case. So we got 1 squared, 2 squared, 5 squared, and then 10 squared, okay? And all the way down here, what is this one? This is the 5 squared case. See, we know, and then finally we get to the 10 squared case. Okay. Now let's just take a look maybe at this one. Let's see if the math is easy here. The arithmetic here. Notice that I'll write the average 12 plus 72 plus 432. And this is just an example. Divided by 3. Okay. Let's see, what is this, ladies and gentlemen? 84, is this 516? Okay, so this is 516 divided by 3. Right, folks? Again, 72 and 12 is 84. 84 and 432, I believe, is 516, yes. But what does that equal to? That is equal to 172, right? But you see that the middle term here is 72, right? But remember the condition had to be 72 plus 100, right? So you can see that meets the condition of the problem. And also, what do we have here? This implies 6 is the common ratio. You see 6 times 12 is 72, 6 times 72 is 432. So you see we get the common ratio and also the first term from this statement, and then we just roll with it. But remember, this was the y plus 100 condition at the beginning of the problem. And y'all, sorry, it's hard for me to keep everything on the same screen, but one of the original conditions was this this y plus 100 condition right here, okay? But in any event, you can check out the others if you want. Let me roll that by just in case you do want to look at that. And all of them meet the conditions, but there's 4 of them, right? You see we have the case for n equals 2. The common ratio is 2, 3, 6, and 11. But as a counting exercise, we were done right here when we said 4. It's manifest that 300 has only 4 perfect square divisors, okay? So anyway, but the answer to the question is definitely 4. I liked it a lot. Again, a JEE, a modification of a JEE examination problem.